Here is the extra practice. This is a Beca problem, and it's been broken down into parts so that it walks you through the process. A solution is prepared by mixing 100 milliliters of 0.100 molar silver nitrate with 100 milliliters of 0.01 molar sodium carbonate. The Ksp of silver carbonate is given. So you know the precipitate is going to be silver carbonate because the Ksp is given for silver carbonate. A, write the equilibrium constant expression for silver carbonate. Here is the Ksp equation, and the Ksp expression is this. So this is what is asked. Ksp expression. 2 silver ions, so silver will be squared and carbonate. B, determine the starting concentrations of silver and carbonate and do a Q calculation to verify that a precipitate forms. So here we have 100 milliliters of 0.1 molar silver nitrate, and the moles will be 0.1 times 0.1, 0.01 moles of from silver nitrate. What we get is silver ion. You can see nitrate is the spectator. So we have 0.01 moles of silver ion, and in the other solution we have 100 milliliters of 0.01 molar sodium carbonate, and you can see what we get from this is the carbonate ion, and it will be 0.001 moles of carbonate ion. Now to get the Q expression is silver and carbonate. To get the silver ion concentration, you have to divide the moles by the total volume because they are going to be mixed up. So 0.2 liters, so 0.01 over 0.2 squared times 0.001 divided by 0.2 liters gives me Q is 1.25 times 10 to the negative 5th, and Q is greater than Ksp. Ksp is 8.10 times 10 to the negative 12. So Q is greater than Ksp, which means more products are present. Products are here, and the equilibrium should shift towards the precipitate, which means the precipitate forms. So we answered this question, verify that a precipitate forms. And now part C here is determine the limiting reactant and the amount of ion in excess after the reaction proceeds. This is your Beca part. Beca, you always have to write the ions forming the precipitate. You are just assuming it is going into completion because you are trying to get the excess reactant, which is going to be the common ion. So before moles, before reaction, before the reaction happens, we have silver 0.01 moles and carbonate we have 0.001 moles, and the change will be the limiting reactant. We can see 0.001 moles of carbonate is going to be the limiting reactant. It is very low amount. So minus 0.001, and this will be actually 2 times, right? So this is 2. So I have made a mistake here, and then so this is going to be changed. So let me do this. This number will be 0.01 minus 0.002 is going to be 0.008 here, divided by 2, because as soon as you get the excess reactant, now this is the excess reactant, we have 0.008 moles of silver ion left after these two react with each other to form the precipitate. We have to immediately get the concentration because we are going to carry this into our ice to get the equilibrium concentrations. So immediately convert this into the concentration. The total volume is 0.2, so 0.008 divided by 0.2 gives me 0.04. Okay, 0.04. So that is how much silver ion in excess. So that is, now the precipitate is forming here. We did not get any data for precipitate because it's a solid. we know that's not going to make a difference. But as soon as the precipitate forms, it's going to dissolve. So then we have to do a ice to find out at equilibrium how much of the ions are present. So initially we have 0.04 moles of silver ion and 0 for carbonate. The change will be plus 2x plus x. So 0.04 plus 2x here and x here, and then we ignore 2x because of the 5% rule, and then Ksp expression is silver plus squared carbonate, and then Ksp value is given 8.10 times 10 to the negative 12 equals 0.04 squared times x, and you get let me see whether there's any change in the number here. I'm getting 8.10 times 10 to the negative 12 divided by 0.04 squared, right? So 5.06, 5 to the negative. So this number is slightly different, right? Okay, 5.06 times 10 to the negative 9. So that is actually my x. X is the equilibrium concentration of carbonate. So that is same as carbonate ion, and silver concentration will be 2 times x plus, and you can see 2 times x is going to be very, very small. It's a 10 to the negative 9. So silver ion concentration will be 0.04. Okay, so that is, we are answering that question. Calculate the concentrations of silver ion and carbonate ion right here. And the other two questions: if the solution evaporated to half of its original volume, would the concentration of silver increase, decrease? This is silver ion that we are talking about. Increase, decrease, or stay the same? When the volume is decreased, the equilibrium will shift to the left, forming more precipitate, which means they will try to maintain the equilibrium will shift towards the precipitate to maintain the concentration. So the silver ion concentration will stay the same. You can see this is actually a stress applied on an equilibrium system. So the concentration, the volume decreased, so the concentration will go up to maintain the concentration same. The equilibrium will shift towards the precipitate. So silver ion concentration will remain the same. Now, why would the moles of silver in solution decrease? Now, the molarity is moles over volume. So when the volume is decreased, to keep the molarity same, according to Le Chatelier's, the molarity has to kept same, right? Moles must decrease. So moles must decrease to keep the molarity same. Right. If potassium carbonate were added to the beaker, the molarity of silver would decrease. Explain why. When potassium carbonate is added, we are just adding carbonate ions to the solution because it's alkali metal salt. You can see the solubility rules are coming into picture here. So carbonate concentration will increase. Here the carbonate concentration will increase, but that is again a stress applied to an equilibrium system. The equilibrium will shift towards the precipitate, thereby using silver ions also. So silver ion concentration increased. All right, thank you.